Hello everyone.
And today's talk is about the sweat and tears of the way we're building the Antenny board. And I have another presenter, Dan. He's also from Red Moon Security, one of our best engineers here. Okay. And what is Antenny? So we have this idea about Antenny satellite base stations by how do we communicate with the satellite? Yeah, of course you need an antenna. So antenna is like one of the things we can solve with SDR radio that we can buy online everywhere. But how to track a satellite in the sky? So we have the ideas to combinations with like a servo motor gimbal that can point towards the different satellite with asthma and elevations. It can, and then it's basically two servo motors, a base one and a elevation one.
Azimuth and elevation.
Yeah, asthma and elevation ones. And we need the PWM signals and power supplies for it. How do I provide PWM signals? One of the very cheap and easy to use solutions is use ESP32, which we have like firmware to enable MicroPython, which you can directly write Python code for it. And one of the benefit of the ESP32 is it's very cheap. It's like $2 or $3 per module, and it can be very efficient to develop on it. And during my undergrad studies, I have published some papers about the MEMS, like using like a single celestial body, sun, to determine the positions. And then it's used like the MEMS sensors, like the gyroscope and compass of your phone. So the idea is like we get the sensor data and the time. We can use it to determine what's the positions you're on the Earth, like from the point by like pointing your phones to the sun.
And to elaborate on that a little bit, we're using specifically fusion sensors, which will take the data from multiple sensors, usually accelerometer, gyroscope, and magnetometer or compass, and then integrate those into a single sensor, quote unquote, that will give you like absolute orientation in space, essentially.
Yeah, so that's basically how we came up with this idea. So we have like our prototype, like this. We have like a power supply, ESP32, and PWM controllers, servo motor gimbals here, and an IMU, like fusion sensors, on the servo motor gimbals to determine the asthma and elevations. And we have like antennas mounted on top of the gimbals. So this setup is like a little bit like not very clean. So we decided why not we combine everything together. By the way, there's a YouTube video online that shows us. It's about how people like development on like this like ideas to combinations of the parts using like breadboard.
Yeah.
That's not very reliable. So we decided we start to build a board to combine all the functions together. So they have.
And just to elaborate, those videos are on our Nyansat website. I believe it's nyan-sat.com, where you can find what we did for DEF CON Safe Mode 2020 last year, and videos of people who received the first version of the Antenny kits and created their own antenna platforms to track satellites and pull some pictures down.
Yeah, this is like pictures of like the first version of like the Antenny board V1. It's quite a bit different than like what it is right now, and we'll get to this later. So how do we build PCBs? Like if you have like a design, how do you prototype it? There's like a bunch of people have their preference of like the go-to like PCB manufacturers. The PCB manufacturer I use, the one is PCBway. It's like one of the largest like PCB prototype suppliers in the world. It's support like PCBs all over the world. Of course, the factory is in China. If you prefer that you're going to use like US supply chain, there's a OSH Park PCBs. So the cons for OSH Park PCBs is not they do not provide SMT service. Right? They cannot assemble it for you. So you have to assemble it for yourself. So and I'm pretty sure people see like Vlog, the guy, and here's a links that provide to you that all the PCB suppliers and he lists on his website. And then PCBway, there's a website for them, and OSH Park PCB, like the supplier from the United States. So we have like our supply chain last year. We do the hackathon, like NAND stuff last year. So what we do, we choose like PCBways to manufacture the PCB for us, and we buy the components from DJKey or Mausers. Because DJKey provide one-day shipment, and it's like pretty fast. Supply chain is awesome. We love it. And ourselves is like Foxconn West. We fast labors of love. We do hand soldering, and one of the cons is like it's time consuming. So we bought a pick and place machine, which is super cool. It can pick up the components for you and put it on the PCB board after you put the solder paste on it. You have to like buy the stencils first. It's great for prototyping, but not great for like bulk productions. So it's like time consuming as well. So DJKey, and this is our pick and place machine. This is basically you load the components on the side, the material stack, and then you load up the program for your PCB design, and then it will load up all the components for you. And then next time we bake it with the ovens we got. That's last year's like solutions. We were able to like build more than like 200 boards and then ship it out like all over the world. Like people love this thing, so we decided, why not we do it again this year's? And it turns out COVID-19 kicks in, and we have like a massive like global chip shortage there. The IMU, the sensor fusions we use, is like from Bosch, 055. It's widely used in automobile, like VR and robotics industry, and it's kind of like popular chips. And I said, why not we use the same chips this year? And I go to like DJKey, nothing in stock, and you cannot buy it like from DJKey, not Mouser, not DJKey, not any like United States like supply chains here you can buy in the state. So there's no way to get it. And then other components like the PWM drivers we're using, they're also not in stock. Of course, also PWM drivers is also what used in automobile industry, and it's hard to get, right? So DJK have options to allow you to put in the orders first, and like they will give the backlog orders for you once they got the part. But that's the date is not, we cannot tolerate that date, like dry 29th, end of dry. We almost have like DEFCON, like,
It's like a couple days ago.
Yes. So, we cannot do it.
What's a PWM driver?
Oh, it's for like controlling the gimbal, servo motor gimbal.
Okay.
So you provide a PWM signals, and it will like using the signals determine the asthma and elevations for.
Yeah, so the PWM chip, you basically, it communicates over I2C, so you like send it commands, and then it has multiple PWM pins. I think it's like with 8 something, 16. There's a bunch. And you can turn each one on and off and select the duty cycle. So for the servo motors, the position is determined by the single pulse duty that you give it. So you give it 90% of the duty cycle, and it'll attempt to go 90% of the servo rotation.
Yep. And this is like the problem we're facing. So there's not many like alternative like parts we can go to. Of course, this one is like we already like developing the code on them, and it's hard to find like equivalent part. And even if we do find an equivalent part, we have to build it and test it out whether it's work or not. It's like there's the lead time, and for us to get the board, it's not going to make it. So that's like a major problem. And from that point, it's like almost like 40 days before DEFCON, we're kind of stuck. That's another issue, and it will slow down your shipment. Before, if you want to buy anything from Hong Kong, you directly buy it. You don't have to. If it's under $4,000 US, you don't have to report the custom. But right now, you have to, and it's like not a great thing. Also, the famous like Silicon Lab like UART to USB chip, the CP2102, is like out of stock. And you only can buy 20 of them, so we need like 200, and there's no way to get them. So, and then like other issues is like if you use PCBway actually their factory is in Shenzhen, and Shenzhen, the bottom part is Hong Kong, and the manufacturer in Shenzhen and imported to Hong Kong, and then from Hong Kong they send it to the United States. It's fast, like it's fast before. Right now it's like slowed down a little bit, but it's not affecting a lot. So I contact the PCBways, redesign the board. Right now we have like the Antenny MK7 board. This is like our latest design. We change like our components to the one I can find. We will talk about later how we find the components, but the PCB manufacturer, we choose first testing batch, we choose like PCBway. And it's like, before it's like reliable, and we're using that a lot. So that's how they like manufacture it and ship it to the United States. But there's like a communication issues. We're running short on like time, and this time we don't want to use like pick and place machines to assemble the board by ourselves. So we let PCBways to order the components and assemble the board in the factory. But here, look at the timeline on the right side. So basically, they always send you questions like early in the morning, because the time difference between China and the United States is 12 hours. That means their afternoon is like our like midnight or something ish, and they must receive the like specific like confirmations of their questions to proceed the manufacture. That means every time they have questions, I see the questions, I reply to them. It takes another days, and if they have more questions and they encounter another questions, it will be a nightmare, because a week is like short, and there's no way to. Yeah, and another like interesting finding is that the sales engineers I'm talking to, they have like their signatures in the email says, "Oh, we're located in Hangzhou, China," which is like north, like pretty north part of China, and the factory is like south part of China. Oh, how does that happen? Hangzhou is near Shanghai, like the place. And I say, how does it happen? Am I talking to the wrong person, or like what has happened? Like I saw like every like package is sending from like Shenzhen, the south part of China. So how does it happen? Like and I do some Google research, and I found out like PCB PCBway is an independent brand of like JDB PCBs. It's dedicating to solving the needs of international customers for PCB proving service. And like their English service center is located in Hong Kong. So I'm actually talking to an agent, a delegate, to people. I speak English, I send them English email, and they forward my message in Chinese to the manufacturer, and then another round back. Oh, that's take a hell of a time.
Yeah.
So I decided, why not and like the same manufacturer actually have their own like the supply chain and like sales engineers. Why not I contact them directly, not through like the PCBway. So turns out, oh, that's work out perfectly. We have like direct contact with like the sales engineers in the manufacturer. We can directly contact to the people who assemble the board and like say the requirement and all the components like very clear. And then we have our like PCB building like supply chain. So what are we going to do with the components? Like get back to the components. Like we cannot find any components on DJT, Mauser. It's hard, but we have like Huaqiang North. Probably people like heard about that. Like Huaqiang North is an area like in Shenzhen, China. It's like one of the largest electronic market in the world. So I don't know any people there, but I'm pretty sure that they might be able to get the components for us, like very fast.
You pirates?
Yeah, and then we have Alibaba, a beautiful website, and then you can find any components on there and the contact with the people. So that's how we get around with like the components with cheap price, and because the Huaqiang North is near the manufacturers in China, so we're able to get the components in time and then sending to manufacturer. So with all the supply chain issues solved, we were able to get the board like 4 days before DEFCON. That's really awesome. And Dan is like holding the board right now, and he's ready to do a workshop and demo for us.
Okay. So, Antenny board. This is as we were saying, like we just got the new hardware a couple days ago. So some of this stuff is still work in progress. We've been refactoring a lot of the code from last year's challenge, to make it easier to develop on, easier to understand. So when you get an Antenny board, let me
Hi.
all right, yeah, can you see it? This is my little construction right here. Wow, that goes in really far. So what we have here is the Antenny board is on a platform up here. Then I have the IMU stuck to the end of the servo gimbal with some wire soldered on. The connection between the IMU and the Antenny board matters a lot for your I2C speed, which will give you just more accurate results. So if you're having trouble with it connecting, reduce your I2C speed. And if you think that it's a little too jittery or too slow, try to increase it, maybe up your wire game a little bit. So the first thing you're going to do when you get an Antenny board is, the first thing you're going to do is install MicroPython. That's documented on MicroPython's website, where you can use the ESP tool to load on the proper firmware, and then you just have a Python interpreter. We'll have that information in the README, but it's a fairly well-documented process. So after you have MicroPython on, if you want to see what that looks like, you should be able to. Another important thing, when you plug in the Antenny board for the first time, when it goes from like cold boot to lights on, you need to press the reset button in order for it to actually boot up properly.
Yeah, actually the newest hardware fixed that problem.
Okay. So this already has the Antenny code loaded, so you'll see some of that, but when you first load MicroPython on, you should just see a Python interpreter like this. It's pretty limited. Do like import os.list here. Okay. So that is the MicroPython portion. So then when you get your board, you clone the repo, which is on RBS Shenanigans. I think there should be when you receive your Antenny board, there should be a ticket with the GitHub link in there. So you run this command. This one. So make nyansat with your serial device. And it'll give you a couple of options. So do you want to keep the configs on the device? Oh, can you see that? It looks like it's cut off a bit.
Let me try to plug the view.
Try
Standard?
side by side. Oh yeah, standard.
Okay.
It's still cut off.
Oh, click on the chat.
Wait, Savino, you're able to see it at least?
Yeah, it's not
Okay.
recording.
Okay.
It's not recording.
So it says, do you want to keep the configs on the device? So that is the configs. There's a couple different configs for different components. They'll map out the hardware, so like where you connected which pins on your Antenny board for each portion. And among other things, you can check out the Antenny config in order to see what it describes. There's an IMU config that will save out, if possible, save out your calibration data. The new IMU that we got saves in a different way. So the config there is not exactly necessary, but if you had a BNO 55 or wanted to get one at some point, you could also do that. And then also it'll save the servo. So the servos have limited range, and that is mapped to a duty cycle that could be different for each servo, so it'll save out that calibration data as well. So I suggest keeping the configs on the device unless you edit the configs in your own repository. So just hit yes there. Do you want to do an installation of all components and libraries? You would hit yes on your first install. I'm going to hit no because I already have it installed and it does take a bit of time. If you do hit no, it'll ask you if you want to install specific components. This is good for development, so if you're only like working on the API, you don't have to upload everything. You can just upload the API code. I'm just going to not install anything. And then you want to reinstall the libraries. So there's libraries, like external libraries included that take the most time to install. So if you want to do it quick and you didn't edit the libraries or add more, just do no on that. And then you'll see, and it'll install all your files. It'll show you how it goes. They'll ask for your Wi-Fi SSID and password. That is not entirely necessary, but you could pip install certain packages. And then there's also a UDP telemetry sender so that you could communicate with your laptop or other Antenny boards. So it's just an option, but it's not necessary. So after you install your code, you can go into the Python interpreter. You're going to want to restart it for it to actually import properly. This is another thing about MicroPython is that there is a boot sequence. So it'll first execute boot.py and then it'll execute main.py automatically on boot. And if any of those error, you won't be able to re-import them without rebooting. So that's just something to keep in mind if you're doing any development on it. It took me a little too long to realize that. So restart it. You can restart it just by exiting the interpreter, just like Control D or something, and it'll just restart. So the first part, the Wi-Fi, is the boot.py portion. And now what we see coming up here is the main.py portion, in which it creates an Antenny API instance. So from the Antenny API, you can do like dir API and see all the commands. There's a lot of them. Most of them are either for debug or development. If you are just using your Antenny, especially for the first time, you would run api.antenny start calibrate and save as default. So what this will do, it kind of meshes together a whole bunch of commands. It'll first initialize components. which I'll actually just run on its own right here. So Antenny and its components, this is something you're going to run on startup. It reads the config and then it sets up your hardware appropriately. So if I run that, you can see it moves to a more generic orientation. It'll tell you what components it's using. So this one is using BNO55. It's using the generic motor since we have not installed, we haven't set it up for a new motor other than the servo gimbal yet. And it is initializing the PID antenna controller down here. So with that, now the next thing you're going to want to do is calibrate the device. So I'll run API Antenny start calibrate and save its default. So there are a couple calibration options. The best one and the one that has worked the best for me is the one I'm going to use here, which is I call it auto calibrate. Essentially, when you have the platform and the IMU together in one assembly, it'll actually use the servo gimbal to calibrate the IMU because the IMU doesn't really like shaking of hands. If you're doing it manually, like without the gimbal, it works best to lay it on the table and then move it in the orientations that it tells you to move it without picking it up off the table because the shaking matters a lot. So, and then the second part of what this command will do is it takes your calibration data. This is more specific for the BNO55, but it also is for the servo. It'll take that calibration data and save it to a file and then make that file start on boot up. So it saves it as the default calibration. So I run this. So what it's doing now is it's going to the extents of the servo, looking for motion in the IMU to figure out when it stops. And then after it does that, it'll start to calibrate the IMU. So this is calibrating the magnometer, in which you are supposed to move it around the compass. This one only has 270 degrees of free range, but it still works, even though they recommend 360. You can see on the bottom there's configuration levels. So the BNOs, they have an internal configuration calibration level, which basically means like how well calibrated am I? It goes from 0 to 3. So this routine will continue to move in the proper orientation until it reaches 3. Takes a little bit of time, but like I said, it'll save it as default, so you should only need to do this once with each setup. And I mean, if you wipe your config, then you'll have to do it again.
Do you have to recalibrate if you move your ground station?
No, there's another step for that I'll bring up after. So this is now calibrating the accelerometer. It tells you just to move it to random orientations and then wait 2 seconds in between. So that's what it does until it's calibrated. Usually stays at 0 for a while and then ticks up pretty fast. So, but this is definitely the most arduous one, and if you're doing it by hand, it's pretty painful, I'm not gonna lie. Even Bosch in their little video talks about how painful it is. So it's not just like it is aggravating. Okay, so calibration is done. So the next thing, as Andres over here alluded to, is it needs to know where that 90-degree dead zone is in the azimuth servo gimbal. Otherwise, it'll kind of freak out if it tries to move there because the azimuth is an absolute orientation. So if you rotate it, the azimuth will change, but that dead zone doesn't change, right? So it needs to know where that dead zone is. There are ways to get around this where you use the elevation to flop it over, or like, as we were talking, yet another dimension. That is a lot of math. Not a big fan of math, so I just use it dead zone. It should be fine. Most satellites go like around, like they'll like always point south, so you're usually just tracking like that. So if just point your dead zone north, and you should be fine. So the next thing you want to do is this command platform orient. So what this does is finds the dead zone. Okay, so we found the dead zone. It's between, so it can go from 93 to 194. So the dead zone there is that, what is it, like 100 degrees between 193 and 194. So you just can't set your azimuth there. The next thing I'm going to do, so as we saw before, we're using the PID controller, platform controller. So what this is going to do, if you're familiar with a PID loop, it'll start a PID loop using the input azimuth and elevation from the IMU as like the feedback, and generating new values for the servo motor to move. So if I run API.platform start, that'll start the PID loop. It runs on interrupt timers, so you just kind of have to start it, and it should just start going. And then I should be able to do API.platform set azimuth, something outside of the dead zone. So let's do 260. And it should start to slowly move over to the azimuth that you give it. It might have been a bit difficult to see, so I'm going to go to, let's say, what does 340 look like? So the PID loop, what it does is it like calculates the error and will like slowly get to the position that you want it. So as I was saying before, if you up the I2C speed on your accelerometer, it'll get smoother and smoother, but also it gets harder and harder to control with the wires. So I'll do an elevation one now. Elevation has a limit of 90, so if I do like, it looks like it's about 45 right now. If I do like 85, oh, it's going the wrong way. That should just be adding a -1 somewhere. It's probably, I'm not sure how that happened. It mustn't work. I've been working on the other hardware mostly, so. If I do 45, it should go back up. So that's basically how you use the antenna platform of the Antenny. There is much more it could potentially do, but it is an open source project. So that is kind of the point.
Yes.
As we just discussed for a while, the supply chain issues have been a problem. So I got the new hardware beginning of this week. It is now Tuesday. So I'm still working on implementing the new IMU. The new Antenny board seems to work fine. There's a couple new MicroPython issues that have been super easy to work out. But yeah, that's basis of it.
Awesome. I guess we'll pretend it's Friday and we'll discuss this on Discord channel.
Yeah.
Me and Dan will both be on the Discord channel answering your questions about the Antenny
Yep.
code.
Antenny code. We'll also, if you're going to be at DEF CON physically, we will be at the booth. If you have your Antenny kit or you have one waiting for you there, we can help you set it up, and I would love to have more people work on the code and make some really cool stuff.
Hope you guys enjoy our little buildings, kits, Antenny board. Thank you.
Yep. Thank you.
See you.